Hey guys, hope that all is well. So today what we're going to be working with is you're actually going to be creating your own Vertex-Edge graphs. So the last couple of days you've been working with them, you've been analyzing them, their parts, basically their degrees and all that. You've been writing algorithms and analyzing algorithms in order to be able to represent Vertex-Edge graphs. Today you're actually going to be creating Vertex-Edge graphs, right? Sorry about that. You're actually going to be making your own Vertex-Edge graphs. You're going to be creating Vertex-Edge graphs. And again, you guys have the hang of it already. So I do feel that it's one of those things where you shouldn't have any issues whatsoever, but it will be one of those things that's more interesting, if for nothing else, just for you to actually be able to apply all this and all that. So the other day you came up with algorithms, right? So the very first thing whenever you're starting is just being able to represent what that graph is, right? So every single Vertex-Edge graph consists of vertices and edges, right? So we have G equals V and E, vertices and edges. And then we're gonna have first all of our vertices represented. So our vertices over here would be H, right? T, we have F, we have L, we have G, and we have O, right? So these are 6 vertices that I'm giving you. And now, so we have vertices, now I have to give you the edges too. And again, it's just one of those things where it's just gonna be the habit of, once you have all this information, being able to analyze it so that you can create a Vertex-Edge graph, right? So the first one I'm gonna give you is gonna be HT, and then it's gonna be it's going to be then HF, HF, and then it's going to be FL, and then it's going to end up being LG, and then GF, and then the last one's going to end up being FO, right? So we have everything that we need to actually create a Vertex-Edge graph. We know our graph's going to be vertices and edges. We have all of our vertices. We have all 6 of our edges. And now with that, let's actually create it. And it's just seeing that again, it seems more complicated than it actually is, but it's not. Again, whenever it comes to this, you don't need this to actually create it. The vertices will know what they are based on this. But our most important thing for creating Vertex-Edge graphs is the edges themselves here. So first one we can start off with is HT, right? So we know we're gonna have H, we know we're gonna have T. And just a heads up guys, not everyone's is always gonna look the same just because there's different ways that you can actually form all this and create all this, you know what I mean? So just keep that in mind, it's not always gonna look the same, but as long as all the information is there, we're okay, right? So we have that first one, HT. The next one, we're gonna have HF. So since it's HF, we know that H is gonna connect to F. And again, I'm just choosing to put it right there, just as a representative, you know what I mean? So far we have HT, we have HF, right? The next one, we have FL. So it's gonna connect F to L. So we have F going to another point, L, right? Again, I just chose to put it there, right? So we have FL. Next, we're going to have LG. So I'm going to put L to G, right? I'll put G right there. So we have that, right? Now, and this is what I mean sometimes. Sometimes you actually have to manipulate it. So we have LG. We need G to connect to F. We need G to connect to F. So what we can do is I can actually manipulate it, right? I can decide where I want to move G somewhere here, right? Because all we needed was LG, so I just decided to end up moving G down here, right? Still have everything that's still the same. HT still there, HF is there, FL is there, LG is still there, but I just wanted to move it to make the other ones work, because in the end, it's still the same information. We now want GF to connect. So we have GF right there, right? And then the last one, we want FO, right? And now FO, there is no O, so let's add another O to F. There you go. That's all it is, guys. That's our Vertex-Edge graph. And when it comes to looking at our Vertex-Edge graph, again, we have all 6 vertices, H, T, F, L, G, O. And then we have all these edges, HT, HF, FL, LG, GF, and FO. And now if we also want to look at the degrees of it, just for us to actually get in the habit of analyzing it, right? You could have analyzed it from here, or just look at it. We know that the degree of O is going to end up just being 1, because it goes to F. We know that the degree of H is 2, because it just goes to F and it goes to T, creates a path there. We know that the degree of T is going to end up being 1, because it just creates a path with H. We know that the degree of F is going to be 1, 2, 3, 4, right? We know that the degree of L is going to end up being 2, because 1, 2 goes to F and G. And the degree of G is going to end up being 2, because it goes to F and it goes to L. So if you were to analyze that, those are all our degrees. And if we wanted to know the degree of the entire graph, the degree would be 4. Just for nothing else, it's the highest degree in the entire graph. So that would be our degree of the graph. Again, if you get into a situation where you have to move things around or move around edges, feel free to do so, guys. But as long as the information is all accurate, that's all that matters. Good luck with this. And again, any questions, feel free to ask. Just have fun with it.